Welcome to Today in Space, and welcome to our newly revamped segment for 2020 called The People of Science, where we're going to break down the common misconception of what someone in science is like. Let's be honest. When I say that someone is a person of science or a scientist, what do you think of? Probably someone in a lab coat, maybe holding a beaker of some kind of neon-colored liquid, maybe some safety glasses if you're lucky. And what we want to do with this segment is introduce you to the people of science that are actually involved in science in some way or another, with whether that means interviewing someone alive today or someone from the past who's no longer with us. There's no limit to the skills or experience of the person either. We want to show you what it means to be a person of science throughout all stages of life. The one thing I realized going to college for aerospace engineering in a school where it was all engineers was that everyone came from different places. Some people were in robotics and rocket clubs. Some had family that was already in science or some kind of scientific field. And some, like myself, had no one. And we're kind of just jumping into it without really understanding what it was like to work in space or to work in science. And that's just the beginning. Whether they're someone that worked on the space shuttle, a Mars rover, discovered dark matter, or just simply helps communicate science to public, there are so many ways that people can be involved in science. We do have a few goals for this segment for the future here. One is to break down the image that scientists are not just people in lab coats, as we already discussed. It's also to introduce you to the diverse spectrum of possibilities that are available in science, and in some cases, the crazy paths that it takes you on in your career. And our big, audacious, long-term goal is to change the way people look at science as a career as we enter a reality where humans can live and work in space and on other planets. The earlier we can show people that this is a reality, the more opportunity and possibilities will be open for all humanity. Now, with that said, if you have anyone you'd like me to interview for the show, please reach out. Hit me up at Today in Space Pod on Instagram and Twitter, on Facebook, on our Today in Space podcast page, or email me at todayinspacepodcast@gmail.com. We also want to know about some famous people of science or maybe not so famous people in science that you'd like us to research and show the human side of. What their career was like, what they thought, their faults, and their achievements. Let us know, and we'll either get them on the show or start researching. So Newton came up with the first gravity equation, which, helped us on Earth. It helped us really explain the basic movements of things around the universe, but it didn't account for everything. And really, when we looked at the universe as a whole, our solar system was okay, but even some of the things in our solar system didn't really account for the things that we thought they would. And then Einstein's theory of general relativity came around. After his theory of special relativity, he tweaked it, made it account for even more things, and helped us explain space and time, which was in turn the universe. But it didn't account for everything. And then Fritz Zwicky pointed us to the missing mass problem in 1937, that if we count up the mass we see and that we can detect, it doesn't compute when you notice how the velocities of those galaxies. It just doesn't paint the whole picture, which means there's something we're not able to detect. And this brings us to our scientist of honor for this episode of People of Science, Vera Rubin. And while I've done a little bit of research, the work has kind of already been done for us. And if you haven't already, I definitely recommend Neil deGrasse Tyson's Astrophysics for People in a Hurry. This actually isn't my copy. This is a friend's copy. Chris, I do apologize. I will get this back to you. But we did get to use it for this week's episode. And so I'll just read basically a few paragraphs here, because this explains everything we need to know about what Vera Rubin has done to help further this mystery along for us with science. Just as astrophysicists had come to accept dark matter in galaxy clusters as a mysterious thing, the problem reared its invisible head once again. In 1976, the late Vera Rubin, an astrophysicist at the Carnegie Institution of Washington, discovered a similar mass anomaly within spiral galaxies themselves. Studying the speeds at which stars orbit their galaxy centers, Rubin first found that what she expected within the visible disk of each galaxy, the stars further from the center move at greater speeds than stars close in. The farther stars have more matter, stars and gas, between themselves and the galaxy center, enabling their higher orbital speeds. Beyond the galaxy's luminous disk, however, one can still find some isolated gas clouds and a few bright stars. Using these objects as tracers of the gravity field exterior to the most luminous parts of the galaxy, where no visible matter adds to the total, Rubin discovered that their orbital speeds, which should now be falling with increasing distance, as you go further out from the galaxy, they should be slowing down, right out there in Nowheresville. In fact, those velocities remained high. And these largely empty volumes of space, the far rural regions of each galaxy, contain too little visible matter to explain the anomalous high orbital speeds of the tracers. Rubin correctly reasoned that some form of dark matter must lie in these far out regions, well beyond the visible edge of each spiral galaxy. Thanks to Rubin's work, we now call these mysterious zones dark matter halos. This halo problem exists under our noses, right in the Milky Way. From galaxy to galaxy and from cluster to cluster, the discrepancy between the mass tallied from visible objects and the object's mass estimated from total gravity ranges from a factor of a few up to, in some cases, a factor of many hundreds. Across the universe, the discrepancy averages to a factor of 6. Cosmic dark matter has about 6 times the total gravity of all visible matter. And so Vera Rubin gave us another piece of the cosmic mystery that science has been looking to explain about the universe. And as it goes with most great answers in science, it actually opened up more questions than it actually answered. Dark matter is a very fascinating thing. We know that it's there by seeing that we can't interact with it. So literally, all these things we're looking, and Vera Rubin is an astrophysicist who's looking at galaxies, just like observing them. We just heard about that. And literally everything that we can account for just doesn't add up. Now, I'm not in the belief that it means that the equation that, Einstein has left for us is wrong. I think it's an equation that just needs to be added on to. And we just haven't figured out how to come across and measure the thing that is not noticeable by us. Now, it's a very interesting thing. I came across a few videos with Neil deGrasse Tyson, and it's always, if you want to see Neil deGrasse Tyson get a little irritated, this is definitely a video for you. It's interesting. Dark matter, as he says, it kind of gives people the wrong impression, which I have turned more towards his thinking on this, because it's not like we've actually detected any matter. It's just that the matter that we know of, the matter that sticks together, that we're all made of, right? The thing that you're holding watching this, or the screen that you're looking at, that is matter that has come together. Those particles are connected by electromagnetism to create more matter. These other particles that we cannot see, we cannot detect, do not interact the same way as these particles. And neutrinos are a perfect example of something that we know the universe is full of, but we never feel them coming through us. There are neutrinos that come from the sun that go right through all of us, and we don't even know. We're no worse for wear, right? Because our particles don't interact. Now, we know about neutrinos because we've figured out a way to detect neutrinos. Maybe there is this other thing out there that we may one day figure out a way to detect, but in order to do that, we need to create something that it will hit or impact. And how do we do that if it's made of the things that it doesn't interact with? So this is the ultimate craziness, and Vera Rubin is an integral part of this continuing mystery of the human experience, and we want to give her due here. Now, because Vera Rubin did pass away and is no longer with us, and Godspeed to her, her memory is still here, and we do have some things that we can look back to get an idea of who she was as a person. How did she think? And there is this amazing thing that I did find, and the more I was able to read her writing, the more I was able to appreciate the kind of thinker that she was and the person that she was. There's a book out of hers. We've got it here. We'll have the link for you. It's called Bright Galaxies and Dark Matters, which introduces the work and some of the thought of. It's actually part of a series called Masters of Modern Physics, which, as they say, introduces the work of and thought of some of the most celebrated physicists of our day. This book was published in 1996. And if you Google the book, it gives you actually like 30 pages or so. So we've got the link. You can check that out here. And in this abstract, which is actually included in those pages, I was able, I fell in love with the scientist Vera Rubin. I was able to read literally her thoughts and better understand who she was as a person. And we're going to try and get her book. It is a little bit pricey, but we'll have the link if you are interested in getting it. But we're going to get that here so that we can dive deeper into her work. And it's such an interesting series. And she is an incredible astrophysicist that we want to learn more about. But for this episode, I want to go through some of my favorite passages here that she's left behind for us to keep her memory eternal. My favorite passage that told me a lot about who she was as a thinker is this.
Scientists too seldom stress the enormity of our ignorance. Virtually everything we know about galaxies we have learned during the last 100 years. Galaxy spectroscopy will soon be 100 years old. A few of the major results are celebrated in A Century of Galaxy Spectroscopy, in part 3 of this book. But what are the questions for future astronomers? What questions will astronomers be asking of the universe 100 years from now? 1,000 years from now? Questions easy to list are the unsolved questions of the present. What is the age of the universe? What is the here and now rate of expansion in the universe? How much mass is there in the universe? What is dark matter? Is its gravitational attraction sufficient to halt the expansion and to start the universe contracting? Do any nearby stars have planets harboring life close enough so that we can communicate in short time? Then there are the questions we barely know enough to ask. A feeble list. Are there other universes? Will we ever communicate with them? How will our concept of the universe alter when gravitons are detected? As we peer into the universe, we are peering into the past. But our eyes are weak and we have not yet seen to great distances. No one promised we would live in the era that would unravel the mysteries of the cosmos. The edge of the universe is far beyond our grasp. Like Columbus, perhaps like the Vikings, we have peered into a world and have seen it more mysterious and more complex than we had imagined. Still more mysteries of the universe remain hidden. Their discovery awaits the adventurous scientists of the future. I like it this way.
It was also very interesting to learn about Vera Rubin's childhood, as I could definitely relate to asking many questions when I was a kid about the world around us.
As far back as I can remember, I was puzzled by the curious workings of the world, and especially of the sky. My earliest recollection is of sitting in the back of a car at night, driving home along the Wissahickon Drive in Philadelphia, and asking my father why the moon is going where we are going. As we traveled, the bushes, trees, and distant hills all passed by, but the moon sat steadily outside my window. How did the moon know we were returning from Bubba Cooper's house in West Philadelphia to our home in Mount Airy, Pennsylvania? Undoubtedly, I was given an answer. Probably I did not understand it, but I can still recall the excitement of the question. And now, some 60 years later, the excitement I get from asking questions of nature is no less. As a youngster, other questions followed, many puzzling for years. Why did the pictures on my bedroom wall jump back and forth on either side of my finger, held in front of my face as I laid in bed blinking my eyes? How did drops of water in a flowing stream know on which side of a rock to pass? Could I, a lazy child, devise a street on which one sidewalk went uphill and one sidewalk went downhill so that I could always walk downhill? These were my puzzles at age 3, 5 or so. Sometimes I voice them aloud, but often not. Thinking back now, I believe that even then, I was more interested in the question than in the answer. I decided at an early age that we inhabit a very curious world. As I grew older and continued to watch the sky, the questions became more conventional, even dull. Some I could puzzle out for myself. How many license plates can be made with 3 numbers and 2 letters? This puzzle I solved as we drove from Pennsylvania to our new home in Washington, D.C. In those Depression years, astronomy questions were answered by library books. Other far-out questions were raised, not answered, in inspiring books by Sir James Jeans. Family friends Goldie and Mike drove Ruth, my sister, and me in their open car to the dark Virginia countryside and named the stars and aligned the planets. My parents, Rose and Pete Cooper, took us to Haines Point to see the spectacular aurora of 1939. These visual experiences were primary in causing me to become an astronomer. Some 40 years later, Goldie was to write to me, "I've been thinking back to those days when we rode out under the stars. It couldn't be done now. Then, when you crossed the bridges into Virginia, you were in the country. Now I feel it a night."
And look, we can relate here in the 21st century here in the Boston area too. But she also gave us a great description of her career and the people she chose to acknowledge when writing the book.
In the random walk that is life, my walk has probably been less random than many. In 1952, age 23, I entered Georgetown University Graduate School to become an astronomer. I had a husband and a child and was pregnant with a second. I had a BA degree in astronomy from Vassar College and an MA in astronomy from Cornell University. That I succeeded in 2 goals, to raise a family and to become an astronomer, is a tribute to many.
And finally, as a not-on-purpose plug of the book, which is expensive, again, the Bright Galaxies and Dark Matters, this last portion really shows how her passion for astronomy and astrophysics and viewing the universe set her up to add to the ever-expanding question of dark matter and what is it? Is it even matter? What is going on in the universe that doesn't make sense? This section just shows us why she was the person that helped with that.
This book is a collection of 35 papers, essays, and talks, extending over 36 years. Several themes occur in these works. The major theme is surely the study of motions of stars and galaxies and the evidence of these motions, that most of the matter in the universe is dark. Such studies have been central to my career for more than 25 years, but the other themes emerge as well. Our nearest, currently known, large spiral neighbor, the Andromeda Galaxy, M31, is a galaxy I study over and over, as new telescopes and equipment offer new opportunities for learning more of its secrets. In this collection, the M31 Galaxy appears in papers from 1973, 1987, and 1995. The careful reader may be able to trace our increased understanding of its complexity, which has come about from the combination of observations, theories, and computer simulations. It is not surprising that the study of the M31 galaxy led me to the studies of rotation of many other galaxies. This book is mainly words. Technical English words. But astronomy is a visual science, and discoveries can be made by looking. As Yogi Berra may have said, you can see a lot by just looking. I have here included galaxy images. I hope the viewer will examine them carefully. Galaxies have their own personalities, just as people do. I hope some of their idiosyncrasies show. And in my talks, I often refer to poems, songs, or paintings. A few of these are included.
And so this is a beautiful way to end this, the first episode of the revamped People of Science. It's not just about the science sometimes. It's about the adventure. It's about being able to ask the question and the adventure of getting to the answer. And there's so many other different things here. I mean, Vera's one of those rare scientists where she seems to be able to combine the more artistic skills that don't usually come with what some people would recognize as a scientist or even an engineer. Although I would say that's definitely wrong of an assumption, as obviously we're a very diverse group of human beings with very different things. This is why we're doing this kind of episode, is just to show this diversity, to show the different kind of people that are out there. And Vera Rubin is definitely one of those people that we felt deserved some praise here, a little bit of a dive into who the person was. This was an amazing find. Thank you, Google Books. But no, we're going to get this book so that we can dive deeper into it and just share more of her work because, as we said, she is a major player in this whole dark matter mystery. And even back in the day, way back before Newton, in the early days, they used to talk about the ether that, there couldn't just be a vacuum of space. There's got to be something that's holding it all together. Why would the universe why would the solar system, why would the planets be spinning the way they are? How are they being held up? Back in the day, they were thinking there's an ether, there's something around it. And of course, there was, back then, even further back, we have, polytheism, we have the gods, we have the Greeks, talking about the gods and how they play with us on a daily basis and they get involved in our lives and play a major part. That's that ether. That's that weird, and I think there's a spiritualism of today that kind of captures this in a non-scientific way. And now we have this expression in science where there is this something that we can't explain that seems to be in the void, in the darkness, where we can't see it. It's not seen. And Vera Rubin is a part of advancing us in that state. And it's because of her love of astronomy and of observing galaxies. And one day she came across something that has now pushed us to further expand our knowledge and get closer to understanding what this crazy reality is that we live in. So we thank you, Vera Rubin, for being the person that you were, for being the scientist that you were. And I hope this helps show that people of science are very wide and ranging and diverse, and we're looking very forward to our next guest here on the show. But for this episode, we leave it to our famous astrophysicist, Vera Rubin. And that does it for this episode. And we want to know who else you'd like us to have on the show. We do have some people lined up, but we want to know who you'd like us to have on, whether they're already involved in science currently, if they've done anything impressive already, or if they're already on their way to making a name for themselves in science. We want to have them here on the show, so no matter their experience, let us know and we'll reach out to them. So you can do that by hitting us up on Today in Space Pod on Instagram and Twitter. You can reach out to us on our Today in Space podcast page on Facebook, and just by emailing us todayinspacepodcast@gmail.com. You can also follow us all there. Please do. We're starting to do some new stuff here on TikTok at Today in Space. We're just kind of sharing my everyday thoughts, how we kind of used to do here on the podcast. It seems like it's a better fit for that. We're also going to be putting that stuff out on our stories on Instagram and Facebook, so you guys can kind of actually check out Today in Space on a daily basis. So we're trying some new things. We'd love for you to obviously check us out, subscribe to us on YouTube, share with folks, spread the word. That's been one of the major things that's gotten us more traction here, is people like you sharing it with other people. So please do that. And of course, as always, Apple Podcasts, Spotify. We're growing a lot here on Spotify. So share the podcast, let people know about us, and I thank you. It wouldn't be here without you, so I appreciate that. And we'll see you next month for more Today in Space. Be good. See you later.